Well, hello folks, welcome to lesson 3 of the Golang for Absolute Beginners series. Today we are going to begin making a guess the number game. However, in order to be able to do that, we really need to be able to talk to the user properly and cope even if they say something they're not supposed to say. We were using before to scan lines, we used scanf, which was a quick way to get numbers in, but it doesn't quite work right if someone says something they're not supposed to, and if there's a space in the thing, it will cause more problems. So today I'm going to be introducing a couple of things so that we can make sure we get the right response from our users. So what we're going to do is we're going to ask them for a number, and then if they don't give us the right number, or if they don't give us a number at all, then we want to be able to say, hold on, that wasn't a number, give us the number again. That's just one way of handling this. I guess the other would be to say, hey, that's rubbish, and turn off. So to do that, we're going to need to use loops. So we need to be able to do the same thing again and again and again. The next thing we're going to need to be able to use, we're going to need to use os.standin. Now standard in, std in, standard in is basically the name in the program for the console. Every program has standard in, standard out, and standard error. It's fairly standard across most programs that they have these three available when you write them, and standard in refers to that console. And to do that, we're going to use the scanner as well, buffered.io, and we're going to scan on standard in. So that means we read everything up to the first new line whenever the person pushes enter. A2I, this is a method that converts string into integers. Even though they look like integers, a string is a set of characters. And if you're given a set of characters that look like a number, somehow we need to make sure that that actually is a number, and this is the function that does that. And when that function's running, sometimes it says, well, hold on a second, I can't convert hello into a number, and it throws an error. We need to find out how to handle that error. So we're going to do that. We'll get onto that in a minute. But first, how did you do with the challenge I set you? I set you the challenge, and I think it was you've got to ask the user for a number, then you've got to ask them for another number, and then add them together and tell them the response. So I'm going to do that in our new lesson because I asked you to do it from the beginning. To do that, I'm going to make a directory. Now today I'm using the editor I normally use, which is Vim. So if I dir, I can just see where I am. Oh, not dir. Oh, that's rubbish. That's where we do. I see. I'm not used to doing this on Linux. I have no idea why this brings up a whole separate window to do something that it should just do in the bottom. But we are going to. We are in the right folder, I'm pretty sure. If I write pwd, it should tell me I'm in programming. Oh, so I need to cd into Golang, and then I'm going to make a directory, but I'm using the, and that directory will be our lesson, and this is lesson 3. Good. And the next thing we need to do is edit lesson 3. Oh darn, I've put this in the wrong place. Move lesson 3 to source. Did that work? Okay, so now we cd source lesson 3. Good. And then we're going to tab edit. That means we're going to open in a new tab, and we'll call it lesson3.go. I have no idea why that hopped over here, but there we go. Apparently we got a file that already exists, or maybe it's just created the file for me. It looks like it's just invented a brand new file. So package main import funct We need thumped, so that's okay. Because we were going to use standard in. So what we're going to do, we're going to print line here. Oh, hello, please give me a number. We'll do a new line, and then 2 of these are red things, and then we'll do thumped dot. So this is our math problem that we were doing. I'm actually going to delete most of this as soon as I'm done. Thumped that that was going to be print line. I should make that print f. Oh, print line is fine. Print f is basically the same, I guess. Oh no, because I wanted to put the 2 things on the next line, I am going to replace that with an f. And then we're going to scan f, and here what we're going to take in is a number %d, and then finish that with a new line, and that will be, oh, and we'll put that into the location of a. So if you remember, when we declared a variable, that variable had to take up a certain amount of space in memory. So var a int var b int thumped.scan f $a. So basically we've taken the location of memory from here and we've put it, just the location is then converted into another variable and sent in this parameter here, and that means that we can, the scanf will put the data in the right place. Thump.scanf %d -n, and this one will be and b. I'm going to copy this and put it here instead, and then put it here, and instead of a number this time it will say another number. The last thing we're going to do is we're going to add them together, so we'll make another no, we don't even need to do this because c colon equals, you could have done this by var c int equals, but if we know a is an int and we know that b is an int, a plus b is going to be an int, and so by using the colon equals instead, then it's able to say, it just works out the type from the type of the 2 variables added together. And then we can do thumped.printf and then it will say, let's do it this way. Let's go %d plus %d equals %d close quote, and these 3 numbers will be a, b, and c. And then if we write this to the file, come over here, oh, it just seems to still be working in this program, there we go, and then we can cd into, with less than 3 now, and now if we run go run less than 3.go, hello, please give me a number, 4, give me another number, 6, 4 plus 6 equals 10, and the program is finished. So that was all I wanted you to do for your challenge. Now we're going to deal with the next part of the problem, which I mentioned, which is what if someone puts the wrong thing. I'll give an example. I'll run the same program again, but this time they say, hello, please give me a number, and they just say okay. That's a very British way of responding to this question. And it doesn't even know what to do with that, so it just treats them as zeros and carries on. In fact, it doesn't even give the user a chance to answer the second question. And that's a problem. That is not what we want. So what we're going to do instead is we are going to make a special function of our own which will be able to do an ask for an int. Okay, so back over here, at the top, we're going to declare a new function, and this is func, and this is ask int, and this will need a message, okay, and that message will be a string. Now, and our return type, I don't know if we've really done return types, but every function can return something to the person who asks, and then if you see it in line in the code, it kind of becomes that result. So this will return an int, and then we use the squiggly braces to get going with the code, and in here we are going to use a couple of different things. Sadly, scanf isn't quite capable, or I find it very difficult to find a good way of getting scanf to do what I want. We want to make sure we read the entire line, whatever happens, and scanf won't do that. If it gets an error, it will stop reading the line. So I want to read the entire line, whether or not we can do anything with it, which means we're going to need to use OS and standard in. So we're going to need to import these packages from the standard library. We need to import something called OS and something called buff.io. And here we're going to make a scanner. Now scanner will just be a normal variable, but that variable will be of type buff.io.scanner. And we're going to write here buff.io.newScanner, which is actually just a method of the class, just like func.printf has methods, or func.printf is a method. buff.io.newScanner is a method, and this takes as its parameter an input stream. The input stream I'm thinking of in this case is standard in, which is the console, as you can see here, and that is called os.stdin, close bracket. So now we have a scanner. The next thing I need to introduce is the idea of a for loop. We want to make sure that we're going to keep asking until we get that. So for. Now this here, everything we do in this loop will last forever. I'll give you a quick example. So if I say, let's have a variable on the outside, var I int equals 1. And then on here we put I equals I plus 1, and then func.printf. It's going to complain that I'm not using it's going to complain that I'm not using stuff that I'm making here, but that's okay. Printf %d, comma I. Okay. Oh, and we'll put it on a new line as well. Now if I run this, we'll see if you can follow. I think it will complain. I think it will say I've started using a scanner and I'm not doing anything with the scanner. So I'm gonna underscore this scanner instead, because that means it's a variable that we're using but not doing anything with. No new variables on left side of the colon equals. Oh, that's in the buff. That's here because that's. Run it again. Does it complain? Hello. Please give me an. Oh, I never actually called the function. So back down here. All of this math stuff is rubbish. I don't. That's a funny thing to say. You'll never hear me saying that about maths in general. I just mean all of this function. And instead we're going to ask int. Oh, replace that with ask int, and our message will be hello. Now when we run this program, you should see it will loop forever, and it will just keep printing numbers that get higher and higher and higher and higher, and it's really, really fast at it. It's already printing numbers in the 4000 range. Now I'm going to push Control C to stop this program from running, because we don't really want that to happen. We need to make sure this loop has a means of finishing. And actually we're going to ask a question. So instead of printf, we don't need this variable, and we don't need I. We need to output the message. So this will be an S, and then we'll put in those two new lines here as well, and this will of course be message. Then we're going to use our scanner, which I'm now going to need to rename, and we're going to tell it to run a scan, scanner.scan, and that will just read up to the next new line. But it won't put it anywhere. We need to use another function to do that, and that is, it's called scanner.text. So scanner.text, like that. So the scanner is an object, but the scanner has properties and methods of its own, and text is a method. Oh, and scan should begin with a capital S, because of course everything that belongs in another package you're going to have to use with a capital S, because you can't access the things that begin with a small s. That's a way of protecting stuff inside your classes. It's scanner.text, and we could just print it out, and for now let's do that so you can see what happens. So s colon equals, that's the string, colon equals scanner.text, and then of course we'll just print line funct.print line we'll use print line. It's basically the same as printf, but well, it's going to just throw it at the screen and put a new line afterwards, so that's perfectly acceptable for what we're after here. And then it's going to ask for another thing. So if we ask in hello, we should find that this loops forever, but it always waits for us, so it won't look like it's going crazy. Undefined scanner. Did I call it the wrong name? Scanner.scan. Can I just not spell? Oh, no, there's the problem. You remember when I took away that colon because it was saying there was no new variable? There we go. It needs that colon because that says we're creating a new variable and I want you to work out its type from the function. Hello, and so now we can write something back, hello back. And so it's printed that and it said hello again for us, and if I say poo, it's written hello and it's asking, and it won't stop, so I'm going to push Control C so we can end the program and use this function to do what it's supposed to do. So we've got the string. Now we're going to try and convert that string to a number, n, comma, well, for now I'm just going to put comma underscore. I will explain this in a minute. Colon equals, ooh, another package. I think I mentioned this at the beginning. We're going to need to do string conversion, string convert. This is yet another library that normally I don't think I'll be introducing libraries this fast, but we do kind of need this because we need to turn those strings into numbers to ask for numbers. So here we are. We're going to use that package strcomv dot, and this has a method called a2i, and that's, I have no idea what the a stands for here, but I know that the I stands for int. So string convert a2i, and that's going to take s as the first parameter, and that will return its new integer value. Now I'm just going to show you what the error is, because this is going to complain if you put in the wrong thing, so we might as well do this. CW error. So we've now declared two variables here, n and error. N is just a number, and error is the error if it doesn't work. Okay, now that error variable can either be nil, which means there was no problem and n is fine, it's a number that comes from the string, or it can be an error. Now here's the clever part about this way of doing things. If n equals nil, I forgot to even mention this idea of the if function. So this is just a question. This will only happen if it's error. If error equals nil, then we haven't got a problem. That nil is the key word for meaning there is nothing in there. It's just not pointing to anything. And if error is nil, that's brilliant. That means that we've been able to convert the number and we can return n. And so the function that the place that called this function, our askInt, will now have that number. Let's say we'll have a name for a variable here. I tend to use n for numbers, but if it's an important thing to say is if I call it n here, it's important to know that this n here is completely unrelated to this n here. This n only exists inside these squiggly braces here, all the way down from this beginning of this 4 to the end of this squiggly brace here. Outside of these squiggly braces, if I was to try and write n, it would say I've never heard of it. The same is true for here. This n only exists inside the function main. And if I was trying to access it out here, it wouldn't. So this is a way of keeping variables safe, is this idea of scope. I could actually declare a variable here. And I'm pretty sure the computer would complain at me for this because I'm trying to declare a new... no, it might just go, no, we're only working with this scoped one. That's most likely. It will say, okay, I'm making a new variable inside this scope and it's going to be unable to access that one as long as this one exists. So, but if we call it something else, and in general, if you're going to use a large package variable, you should give it a very appropriate name. So you could say package n in this. I mean, it doesn't matter right now. The important thing is that n here is not the same as the n in there. So if we do askInt, now we can do something like print, we'll use fumt dot print f you chose colon %d, because we're going to put out the int, and then n. And we'll make this instead choose a number. So the askInt will now, the first thing it will do is it will create this scanner, which we're going to use repeatedly if we keep getting complaints, but only once. And then we're basically finished actually. We need to, instead of outputting this s, we can write this should be a printf again. And this will be error colon, then we use a little quotes %s is not a number. And this should be a big quote because that closes the actual string. And then the last thing we need to put is the name of the variable, and that is actually going to be s. So this for loop won't go forever. This for loop will go as long as it takes to get an actual int from the input stream, and then as soon as it gets an int, it will do the next thing. So the theory is that this is actually going to work. Let's expect some errors though. Oh no, here we are, choose a number. So if I say hello, error, hello is not a number, choose a number. Oh, we needed a new line there, I think. So now we choose 5. Now it's say you chose 5 and the program finishes. Is that what you expected? I'm going to run through it really slowly again and see if we can find all of the things that happened. So back over here. Here is our function main. This is where the program begins. It goes n colon equals ask int choose a number. So the string choose a number appears, now becomes the message. That's basically how parameters work. It goes from all the way down here. This becomes the middle of this here. And then the scanner looks for standard in. And then we begin this loop, and this loop will carry on until we hit return to leave it. And return basically leaves the whole function and goes right back to, and then n will become this ask int here. Well, ask int here will become that n here, which will then be placed into this variable here, which again is different from this one. But it will only do that. So it scans, and then a property of the scanner then becomes its text. And then we grab that text, stick it in S, and then N, an error, string convert A2IS. So this is our attempt to convert that string into a number. If it can't be converted into a number, I don't know what N will be, but error will be something. But if error is not anything, then we leave the function, just like we did when the person put in 5. But when the person put in hello, that didn't happen. Instead it came here and said error. This %s became the hello, which was s, is not a number, and that's the s here. And then it got to the end. When it got to the end of the function, it went right to the end of the for loop. It went right to the beginning of the for loop again and started over. So now we have a function that asks for an integer and doesn't cause too many complaints. So we can actually on lots of occasions ask for a number now. So remember that program we wrote at the beginning? This is going to be a lot simpler now. A colon equals ask int. Notice I don't even need to declare that in advance because I'm not using scanf. I'm using ask int, which guaranteed to return an int. Ask int choose a number, and then B colon equals ask int choose another number. C colon equals A plus B. Func.print f Oh, I just remembered I needed a new line. Here. Printf %d plus %d equals %d, and that's the 3 numbers in our thing, and then a new line as well because why not? And that's A, comma B and C. So our main function looks a lot tidier as a result. By sticking this in a function, we were able to get the safety we wanted as well as making this simpler on the outside. So that's why we use functions. So I run this program again. Say choose a number, 7. Choose another number, poo. Poo is not a number, choose another number. Okay, 4. Okay, 7 plus 4 is 11. Okay, I think we're ready to try and begin this game then. So we've got our number asking bit. The rest of it's actually relatively simple. We're going to make another for loop over here. So answer equals 7. Let's make it 35. Okay. Oh, and we should make it colon equals. And we'll declare it an int, because int, var answer int equals 35. Okay, and then we're going to ask int, say, let's first print out func.printf print line, I'm thinking of a number. And then take a guess. We'll use this in a for loop. So for, and we'll stick that here. And then we'll go a colon equals, no, it's g for guess. G colon equals ask int take a guess. Then if g is equal to answer, what do we want to do? We want to say we're going to print line you got it and return, and that's our way out of the program, right? Print line, func.print line you got it, and then we'll return. And everything inside these braces here, these wiggly braces, happens if g is equal to the answer. This double equals is the way we ask if two things are equal, because when we use a single equals, that actually makes the left equal to what's on the right. This doesn't change anything. This just asks if they are the same, and if they are the same, it goes into this loop. I'll do something about Boolean variables at some point soon, but basically that becomes true. Otherwise, it's not the answer. Now we need to say if g is less than answer, we want to say try func.println try, say nope higher. So our answer is higher. And then another magical keyword, else. It basically means otherwise. It'll only do this if the other one wasn't true. So if we already know that g isn't answer, because if it was, it would have returned, and that would have ended the program. But here we found out that g is less than answer, so else means g must be bigger than answer. So here we can do func.println nope lower, and again all of this lot, we don't need that anymore, and I'm pretty sure that's our game. It won't be a very good game because it's, of course, it's only got the answer 35, but I'm going to change that in a minute. I'm thinking of a number. Take a guess. So if I say 9, is it nope, higher? What if I say 100? Take a guess. Nope, lower. What if I say 30? 30 is not a number. 30 is a number. Okay. If I say 30, no, higher. So we know it's higher than, we know it's 35, don't we? So we do 35, you got it, and the program finishes. So we got our guessing game. The thing we need to do, and the thing we're going to happen next week, is a challenge where we add, where the number will become a random number. And then we're going to do it so that the answer goes the other way around. So the computer is trying to guess our number. that's next week's side of the challenge, and as the computer tries to guess our number, we will need to work with a slightly different set of questions. Your challenge for this week. I'm surprised by how easy this was to actually put together once we had the number thing ready. So, your challenge for this week is a counting function. So what you're going to do is you're going to use the for loop that I've just shown you, and you're going to start with a variable on the outside of this. So you're going to make a new variable, call it whatever you like, and then you're going to begin the for loop, and then inside the for loop you're going to add 1 to that variable, and you're going to print that variable to the screen, that number. And you're going to do that until that number reaches 100. And when it reaches 100, you're going to stop, use the return keyword, and leave the program. We'll do more about for loops next week, and there are more clever ways of leaving for loops than this. But for now, that's what I want you to do. Don't forget to like and subscribe. I hope you've enjoyed this video. See you soon.